phi r minus r sine squared theta. So these are the two Christoffel symbols that we calculated in the previous video. Now we move to some other Christoffel symbols. So second thing, okay, so here now what we are going to do is that we are going to differentiate our Lagrangian with respect to theta. In previous we have done it with the derivative with respect to the r and r dot. Here theta dot and theta, and minus del L by del theta is equals to 0. Hope you know what the Lagrangian is, and if you don't, let me write the Lagrangian here. So Lagrangian is equal to 1 by half into mass into r dot square plus r square theta dot square plus r square sine square theta phi dot square. So this was our Lagrangian. What we are going to do the calculations. First of all, we are going to do del L by del theta. Okay, here is theta and here is theta dot. Okay, here is theta, here is theta dot. So del L by del theta, doing this will be 1 by half 1 minute, let me, okay, so first of all del L by del theta, and it is equal to 1 by half mass into this term will become 0, and if I'm doing it with respect to theta, this is also 0, and the only term that we are left is with this term, which is r square and the derivation of and the derivative, which is r sine squared theta. So it will be r square sine squared theta, here should be minus, and here should be plus r square cos squared theta. Okay, and here phi dot square phi. Okay, now this should be equal to del L by del theta should be equal to 1 by half mass into, if you do this particular calculations, what it can be, okay, so doing the derivative of sine theta and sine theta, applying the chain rule, first of all, oh 1 minute, there is a wrong differentiation here. Okay, sorry for this. First we will differentiate sine theta, and then we will got what, r square cos theta sine theta, then plus r square cos theta sine theta, and here phi dot square. So I have done the product rule, I guess, wrong, and I misinterpreted the terms. Okay, so these are our expressions. Now del L by del theta is equal to, simplifying it, 1 by half mass into, this will become 2r square cos theta sine theta, and here phi dot square. Now these two will cut out, and what we are left is with del L by del theta should be equal to okay, m r square cos theta sine theta phi dot square. So these are terms. Now this is, let's say, our equation number 1. Now what we are going to calculate is del L by del theta dot. Okay, now del theta dot, so if you remember the equation of Lagrangian, when we will do with theta dot, this term and this term, this term and this term equals to 0. Okay, and only term we are left with this particular term. So if we calculate, it should be equal to 2r square theta dot. Okay, this should be our thing. And now calculating the derivative, which is d by dt of del L by del theta dot, equals to, we are doing here the product rule. So first of all, doing the derivative of this, then derivative of this, which is equal to 4 r square r dot, and here it should be theta dot plus 2r square theta dot. So, okay, so these are our terms here. Now plugging this value and the value that we have derived, del L by del theta, in our Euler-Lagrange equation. So let's see what will happen. So after plugging it, it will be 4r square r dot theta dot plus 2r square theta dot then minus this expression that equals to minus this expression mr square cos theta sin theta phi dot square and equals to of course 0. So this is our equation. Now what we can do is that we can cut out all the sorry, here is one mistake. There should be theta double dot. Okay, this is the double derivative. See, theta double dot. Okay, now what we are left is with these two equations. So let's see how we can compare this. First of all, we are simplifying these things, and after simplifying, let's see what will happen. 1 minute, I guess. Oh, why I'm doing this mistake. So here there is a quite mistake. Then we calculate del L by del theta. I forget it by multiplying with 1 by half into m. Sorry for this, very sorry. And again this equation should be multiplied 1 by half into m, and if you multiply with 1 by half into m, this term should be r square theta dot. Okay, and after r square theta dot it should be del L by del theta, and this expression should be also different. So let me write it clearly. Sorry for this mistake. Actually in previous video also I have done these types of minor mistakes. Sorry for this, but I don't know, I always forget to do this. Okay, so let me recalculate the things. So del L by del theta dot is equals to 1 by half into mass into the term inside, and I guess the term was 2 r square theta dot here, no double dot, 1 minute, r square theta dot, only single dot. And now if we calculate the time derivative, which is d by dt of del L by del theta dot, and then this 2 and 2 will cut out, and what we are left is with the equations m. So let me simplify this, m r square theta dot. Okay, so now we are going to do chain rule, which is 2m r, and then here dr by dt, then theta dot, and then plus mr square theta double dot, double time derivative. Okay, now if I simplify this term, it will become 2mr into r dot and theta dot plus mr square theta double dot. So this is our expression. Now we'll plug this into the Lagrangian equation, which is 2m, okay, 2m r dot theta dot plus mr square theta double dot, and it should be minus our previous equations. What was our previous equation? It was where it is, this mr square cos theta sin theta phi dot square. Okay, mr square sin theta cos theta phi dot square and equals to of course 0. So this is our equation. Now we are going to simplify this. Let's see what will happen. Okay, so here let me cancel the mass term first. Mass will cut out, 1 r will cut out, and you are left with as 2 r dot theta dot and plus mr theta double dot and minus r sin theta cos theta phi dot square equals to 0. Now again rearranging the terms, mr theta double dot, sorry, here should be no m, sorry, r double dot theta minus r sin theta cos theta phi dot square, and then plus 2r dot theta dot. Okay, and it should be of course equals to 0. So this is our expression. Now what we can do is to compare this with the geodesic equation. So now what we can do is we can divide the whole equation by r. Okay, so dividing the whole equation by r, so r and divided by r. Let's see what will happen. This r and r will cut out, this r and r will cut out, and this equation will be theta double dot minus sine theta cos theta phi dot square plus 2 by r dot theta dot equals to 0. Now let's see here, very important thing, this what I'm going to do this. I am writing this equation, this part as it is, sine theta cos theta and phi dot square. What I'm doing is that I'm doing 1 by r, first of all writing r dot and theta dot, then plus 1 by r theta dot first and then r dot. So yes, we can write this because they are symmetrics, because they are symmetry indices. So if you remember, in the first video I have discussed about the different types of the symmetric indices. So I can write this as the sum of these two while deriving the geodesic equation. You can see this particular thing while I was deriving it. So I can write this as the sum of two. Now if I compare this with the geodesic equation, which is nothing, it's x tau minus the Christoffel symbol I, Christoffel symbol tau jk q dot j q dot k equals to 0. This is our equation. And if we want to compare this, what we see is that here in place of x tau there is theta double dot. Yes, this is true. And if you compare, there are 1 2 3 equations. Now the role of x dot j x dot k is played by phi dot square in this particular equation, played by r dot theta dot in this particular equation, and played by theta dot r dot in this particular situation. So it means all the coefficients are the Christoffel symbol. So yes, here see very carefully, this Christoffel symbol, one Christoffel symbol is this, one Christoffel symbol is 1 by r, and the another Christoffel symbol is also 1 by r. So we got our Christoffel symbol. So first Christoffel symbol is tau theta, and if this is phi, it is equals to the minus sine theta cos theta. So this is our first Christoffel symbol that we obtained from this. Now the second Christoffel symbol is what? Second Christoffel symbol is this 1 by r. So this Christoffel symbol can be written as tau theta and r theta, and it is equals to 1 by r. And our third is tau theta r is equals to 1 by r. What you can see here is that the Christoffel symbols here are equal. Yes, what I have said is that here these two r dot theta, theta dot r, and theta dot r and r dot theta is same. There's no matter what you write, theta dot first or r dot first, both are the same equations. It means these two Christoffel symbols are equal. So what I'm going to do, I'm going to remove this sign and equate this as big equal to. It means capital gamma, which is Christoffel symbol theta is equal to the Christoffel symbol theta r. You can see here, only thing is that here theta is first, r is after the theta. Here r is first and theta is after the r. So yes, these two are the same Christoffel symbols. Okay, so we have derived the three Christoffel symbol. But if we do equations, if you see that these two are the same Christoffel symbol, then yes, only two we have derived from this equation.